All right. First, we're going to deal with this negative exponent. So we are going to flip this fraction, and then the exponent becomes positive. So it is going to be 3x over negative 2a, all to the positive 2. For the second term, anything to the 0 power is 1, so minus 1. And we can go ahead and square everything in this third term. So 3 squared is 9, x squared is x squared, 2 squared is 4, and a squared is a squared. And we're going to do the same thing with the first term here. We're going to square everything that's inside the parentheses. So 3 squared is 9, x squared is x squared, negative 2 squared, negative 2 times negative 2 is positive 4, and then a squared. So I'm just going to copy down the rest of the problem. So for the two fractions, the first term and the third term, since they have a common denominator, we can go ahead and add. So that's 4a squared, that's the denominator. 9x squared plus another 9x squared is a total of 18x squared minus 1. And we can reduce the 18 and the 4. 2 goes into both of them, so this is 9, and that's 2. So we have 9x squared over 2a squared minus 1, and that's the answer. So we're dividing two fractions in here. What we're going to do is we're going to keep the first one, change this to multiplication, and flip the second one. That's I call this keep, change, flip. That's how you divide two fractions. You keep the first one, you change the division to a multiplication, and you flip the second fraction. So we're going to keep the first one, change division to multiplication, and flip the fraction. Flip the second fraction, that is. Okay, now what we're going to do is we're going to factor every term. We're going to factor, I'm sorry, not every term, but we're going to factor every numerator and every denominator. And if we can reduce anything, we're going to reduce, and then we will multiply. So let's start with the first fraction, the numerator of the first fraction. To factor that, both of these terms have a GCF, a greatest common factor, and that is x. In other words, x goes into both of them. So we're going to factor that out. So we're left with x squared minus 9. That's like dividing both of these terms by x. Okay, so now it's out here. We did the opposite of distribution. See, if you distribute the x back into this parentheses, meaning multiply it by this, you get the original numerator back. Okay, and to factor the denominator of this first fraction, we say to ourselves, we're looking for two numbers that multiply to give us negative 6 and add to 1. The 1 being right here, that coming from there. Okay, so two numbers that multiply to negative 6. The negative 6 is the constant. Okay, and add to 1. Well, those two numbers are 3 and 2, but one of them has to be negative because we want negative 6. So it's the 2 that's going to be negative. So the factors become x plus 3 times x minus 2. Now we're going to factor the numerator of the second fraction. What we do first, They don't have a GCF, okay? It's similar to what we just factored before, except the leading coefficient, the number that's multiplied by the x squared, is not 1 here, it's 2. So we have a couple of extra steps. We multiply the 2 by the 6. That's a times c. Okay, so that's 12. We ask ourselves, two numbers that multiply to give us 12, but they add to negative 7. Well, those two numbers are negative 4 and negative 3. Okay, so what I do here, I have a little trick I use for doing this factoring. Okay, well, I'm going to do it on the side here. So what I do is I put the 2x, that's what we started off with. We started with 2x squared. So we're going to put 2x and 2x in both sets of parentheses. You always put the 2 in both, okay? Whatever the leading coefficient is, you put that in both parentheses. Now I'm going to put the minus 4 and the minus 3 in here. But we're not done. What we do is we look to see if either of these parentheses have a GCF. This first one does. Sometimes they both do, sometimes only one of them does. The second one, they don't have anything in common. So here, they both have a 2 in common, so that goes away, and this becomes a 1, and that becomes a 2. So the factor is x minus 2 times 2x minus 3. Now we're going to do that same similar thing to this denominator. So we do 2 times negative 3, that's negative 6. And our b is negative 1. That's the, go away, that's the coefficient of our x term. That's negative 1. So two numbers that multiply to give us negative 6 and add to negative 3. Add to negative 1, I'm sorry. So that's negative 3 and 2. So here we go again, using that trick. We're going to put 2x, that's our c, our a, I'm sorry. 2x and 2x into both, and now we put negative 3 and 2, positive 2. We look to see the first set of parentheses doesn't have any GCF, nothing in common, but the second set does. 2 goes into both of them. Oops, I did not mean to do that. So we divide by 2, if it'll let me. I'll do it over here. Okay, so, oh, here we go again. So we cancel. That 2 becomes a 1, that 2 becomes a 1, and that 2 becomes a 1. So it gets factored into 2x minus 3 times x plus 1. Okay, we're almost ready to cancel, but we do have one other thing that we gotta factor, and that's the numerator, this x squared minus 9, that's a difference of two squares, and that gets factored into x minus 3 times x plus 3. That's how you factor difference of squares. So now we have a bunch of, let me erase this so it doesn't. We have a bunch of factors which we can reduce. Okay, so let's see. We have an x minus 2 here that reduces with this x minus 2. We have, what else do we have? An x plus 3. So there's an x plus 3 here. So that cancels with the x plus 3 here. We have a 2x minus 3 on top and a 2x minus 3 on the bottom. So we're left with an x minus 3. That's all that's on the top for every. everything, and then on the bottom we have an x plus 1. So that's our answer.